Hello, in this tutorial we are going to check how to use the template processing features of the async HTTP web server libraries for the ESP32. We are also going to be using the Arduino core. As target board, I'm going to use an ESP32 Firebeetle board from DFRobot. So basically, the template processing features allow us to define some kind of placeholders in textual content, and then when returning an answer back to the client, we can basically replace those placeholders with values determined at runtime. Well, the importance of this is usually related with returning back to the client HTML code. So imagine that you are defining a typical HTML page with some HTML elements, some CSS, and then inside that page you have you want to return to the client a measurement. So you have a very beautiful HTML page to show to the client a temperature measurement with some nice dashboards or something like that. So the measurement will vary with conditions of the environment. So if the client asks for that page multiple times, the measurement, the temperature measurement will probably change over time. So one way you could tackle this would be creating the HTML page dynamically by concatenating the different parts of that page and placing obviously the measurements in the middle, and that would be the part that would be changing over time. But now imagine that instead of just showing one measurement, you want to show like 10 different types of measurements in your page. Well, the code would quickly start to become a mess because you would have to be concatenating strings, and that would not scale well. So what many HTTP server libraries and other frameworks, not only this one obviously, offer is a template processing engine where we can specify placeholders or other more complex structures and generate part of the HTML code. And this is typically aimed to creating dynamic HTML pages, but there are of course other use cases. But they allow to build parts of the HTML page dynamically with variables known only at runtime. And basically, the HTTP async web server libraries also offer that possibility. It's a very simple template engine, but it's very useful, as we will see in a minute. So to get started, just as a quick recap, we start our codes as usual by importing all the libraries we need in order to connect the ESP32 to the Wi-Fi network and to configure the async web server. Then we need the credentials of the Wi-Fi network so we can connect to it. And then here I'm just declaring a very simple string with some HTML content. Obviously, to keep things simple, I'm not going to develop here a big web page, but rather, as you can see here, I have a paragraph element, and I'm assuming that the content of this paragraph could be something dynamic. In our case, we are going to replace it by another string, another predefined one. But imagine that this is a measurement, and you could be replacing this placeholder by something that varies over time, which is a realistic use case. So basically, this is a bit of HTML that we are going to return back to the client. So additionally, as usual, you'll need an object of class async web server, and this is the object that we usually use in order to configure our web server. I'm going to jump this function and we are going to go back to it in a minute because I'm going to cover first the configuration of the routes of the server. So moving on to the setup function, as usual, we open a serial connection, we connect the ESP32 to the Wi-Fi network, and we print a local IP assigned to it so the client will be able to reach this server. After that, we need to configure the routes of our server, and in this case, to keep things simple, we are going to have a single route. We are going to call it hello, and we are going to listen to only HTTP GET requests, and then we are going to define here our route handling function. So basically, what we are going to do is return back to the client an answer. And in this case, although we usually use the send method, in this case we are going to use this variant of the send method, which is send underscore p, which allows to return us precisely what we would do before, like an HTTP status code, the content type, and the actual content. But additionally, we can specify here a function. We are calling it processor in the sense that it will be processing our content, and it will be replacing the placeholders that it has there by other content. So far, this is pretty much what we have been doing so far, calling a send method on our async web server request, or in this case, a variant of the send method. Note that this is not an overload version of the send method, is a different method called send underscore p, but it's very similar in its essence. So, and as I was saying, the new parameter that we have here is this processor, which is a function. Basically, this function needs to follow a certain signature, but we'll get there in a minute. So just to finalize the code of the setup function, as usual, we call the begin method on our server object, and from this point onward, the server should be listening to incoming HTTP requests, and then, as usual, the empty main loop because we don't have any additional logic. So, going back to this processor function, this function was the one we have defined here, and before I have just jumped through it, but now we are going to analyze it in detail. So this processor function is where we are going to implement all the logic related with replacing the placeholders of our text, of the text content that we are returning to the client. So as we saw here, this HTML string add this placeholder, and as you can see here, the placeholder needs to be enclosed in percentage signs, so a percentage sign on each side, and then the name of the placeholder. Here, for illustration purposes, I called it placeholder in uppercase, but it could be something else. It could be just placeholder underscore something, and it would work as well, because it makes sense for us to be able to have multiple placeholders on our textual content. But for illustration, I called it placeholder in uppercase, but keep in mind that it can be something different. But no matter what you put here as the name of the placeholder, don't forget to put the enclosing percentage signs. So, and basically, we'll need to specify how this placeholder will be substituted, will be replaced by something. And this is what we are going to implement in this processor function. Again, the name is arbitrary. It doesn't need to be called processor. You can call it wherever you want, as long as you respect this signature. So this function should return a string, and also should receive as input the address of a constant string. Okay, sorry, a reference to a constant string. So basically, this is the signature of our processor function. And here, this var, basically, I've called this also an arbitrary name, but this is a value that will be injected in our processor function when the request is received in the route, and then when we are returning the answer to the client. And in that event of returning the answer to the client, this processor function will be called, and there we will have it will be injected the value of the placeholders that we have in our textual content. So in this case, we have a single placeholder. So this var should take the value of the string placeholder. And here, as you can see here, I'm defining a very simple logic. So if this var is equal to placeholder, then I need to return the string that should replace our placeholder. Note that this is a very simple logic, but I could have here more conditions. Imagine that I had two placeholders. I could have here var equals to placeholder 2. So if that's the case, I could define here another return value if I had, for example, a second placeholder on my textual content. So this processor function should be called as many times as we have placeholders in our textual content, okay? So this is basically how the template processing engine works. Uh, so as you can see here, for our simple use case, we just have this if catching all the cases that can occur, but this is a good practice, and in the example in the examples that are on the HTTP web server libraries, we should return an empty string as the default case. So if by some reason the placeholder is not matched, we return an empty string, but this is just an additional safeguard because this should never happen unless you wrongly compare here the value of the placeholder. So again, don't forget, when you are defining the textual content, you place your placeholder enclosed in percentage signs, but then in your handling function, in your processor handling function, you'll just receive the name of the placeholder and not the percentage signs. So pretty much this is it. I'm just here printing what is received in this processor so we can check it in the serial monitor. But this is it. This is how you define a placeholder and how you define a function to replace this placeholder dynamically. Now I've already uploaded the code to my ESP32, as you can see here. So it is already connected to the Wi-Fi network, and it already printed back the local IP assigned to it. And now we are going to access to our hello route and check what will happen. So as you can see here, this is the rendered web page. But if we see the source code, although we have defined in our source code the original HTML had here the placeholder, as you can see here, what is returned to the client, it's our nice string that we defined in our processor function. Okay, so if we go back to the serial monitor, as you can see here, our processor function is printing the value that it received. And as I have said before, it is the word placeholder, the name of the placeholder, without the percentage signs. So, and this is it, pretty much. There's nothing very complex about this. It's just a very simple templating engine, and you can use it for replacing with the stuff you need before returning back the content to the client. And obviously you can test with multiple placeholders, and you just need to add more if conditions to your placeholder, to your template processor function. So thank you very much for watching. Hope you have enjoyed.